Okay, Destiny, I'm going to comment on your VOD a little bit. The people that you were talking to, I don't know who they are, but they definitely don't know what they're talking about in regards to artificial intelligence or machine learning in general. And there's a few reasons why it's a little bit absurd. Like, first of all, when they were talking about quantum computing, they were referring to quantum computing as a highly parallelized architecture, which it's not. It's super powerful, but the way it works has nothing to do with parallelization. That's a really hard word to say. But effectively what quantum computing is, if you understand what like transistors on a CPU do, they store state, which can either be on or you pass a certain voltage and then it's considered on. Did I say on twice? Whatever. It's off or on. So it can either store the value 0 or it can store the value of 1. So 1 bit of data can store 2 possible values. With quantum computing, what it does is it actually detects the superposition of an electron, I believe, and it can store multiple types of data. So I think the quantum computers that MIT is fooling around with can store 4 superpositions. So instead of having binary data, we have quaternary data. So 1 bit of data can hold 4 possible values, which is insanely more powerful, but it's still a single-threaded application. So there talks about quantum computing causing major leaps in artificial intelligence because you can do a lot more genetic algorithm iterations is fucking incorrect. You can do them faster, but you can't do more of them at the same time. Secondly, when they were talking about neural networks and genetic algorithms, they didn't mention that explicitly, but they were implicitly talking about those things when they were talking about iterating over generations. That's genetic algorithms. So the way genetic algorithms work is you define an imperative. You tell the program what is good, and then after doing a bunch of random iterations, it figures out what is good based off what it's told is good. So, for example, if you had a game that played Super Mario, you tell it an imperative, which is going right is good, and going right in a short amount of time is better. So it'll start doing random shit at first, and then after thousands and thousands of generations, it'll start to play the game pretty well because it's told to go right. The problem comes with a generalized soft AI, a quote-unquote a true AI, is that a true AI has self-determined imperatives. And the reason that we're not making incremental progress towards that is because no one has figured out any possible way to even approach a self-deterministic AI. So, like with Google's DeepMind, for example, this has made 0 progress towards a true AI because what the Google DeepMind has done is create a generalized framework for AI applications. So, for example, like AlphaGo or the StarCraft AI, these are applications of the framework that people have meshed specifically with their own self-determined imperatives for what is good. Like, for example, in StarCraft, living long is good, destroying buildings is good, preserving your army is good. These are all things that the programmers had to explicitly tell the framework which is good. There's no crossover between having a generalized AI framework and a soft generalized AI. What else? Yeah, so the thing that people should be concerned of, if anything, with AI applications is... I'm like playing with shit right now. The thing that we should be concerned about is it's a theorized thing, and there's people that have written stories and papers about it, but look up the term gray goo. The term gray goo applies to a sort of a boundless AI that's not governed by anything, and it's optimizing things which it thinks is good, but it's actually destroying all of humanity. The most popular one is probably called the paperclip optimizer. So you create a very powerful boundless AI, and you tell it, hey, I want paper clips. So what the AI does is like, okay, paper clips are good. Paper clips are the only thing that I know is good in this world. So what it does initially is it starts going around the office and it starts collecting all the paper clips, and it makes a little pile of them. It's like, hey, that's nice. But then it runs out of opportunity to get paper clips just by picking them up. So then it's like, okay, well, the office has money, so I'm going to figure out a way to use the office's money to buy paper clips and have them shipped to the office. And eventually the office runs out of money. So then it's like, well, shit. There's plenty of paperclip manufacturers. So then it starts hacking into these places, and over time it figures out how to control the machines and manufacture them himself. And then eventually these machines run out of resources. So then he's like, it starts to have this snowball progression where it's like, okay, all of the easy options are now exhausted, so now I have to start manufacturing the aluminum and steel that goes into making paper clips. And fundamentally everything is carbon, so it starts harvesting the carbon from the earth and the carbon from the life forms on earth to start manufacturing paper clips. And then eventually the total extreme is the heat death of the universe and everything becomes paper clips. That is the realistic fear for where AI is progressing, and even that is like, it's kind of absurd to think of because it's so easy to govern AI systems that it's just not realistic that it would ever happen, and it would be squashed before it even gets there. But as far as an AI determining its own imperatives and then learning on them is just, it's an absurdity that we haven't even brushed the surface of, let alone have incremental progress towards. So yeah, I hope that makes sense, buddy. People you're talking to are dipshits, but yeah, take it easy.